unit circle stuff, even some of it we're going to relate back to chapter 4 when we graphed all those. We're talking about inverses. Now we've done inverses, you did them in Algebra 2, we did them in college algebra, and we know an inverse is kind of like the opposite of something. So it's when we reverse the x and y values and figured out essentially what undid a function. We're doing the same type of thing except with our trig functions. Now you've had problems before where you were doing something along the lines of an inverse, we just didn't call it that. Like I would ask you when sine theta was equal to 1/2. And I would tell you you're in quadrant 1, so when is sine theta equals 1/2? And that is really doing an inverse. You are going to be finding that missing angle here. We have a little bit of background before we get into that, so going back to college algebra and reviewing some things along those lines. We know that in a function, each x corresponds to a y, right? If a function is 1-to-1, so function means x doesn't repeat. If it's 1-to-1, that means the y's don't repeat. And those are the functions that we need when we find an inverse. Because the problem is, we know if it's a function, it has to pass the vertical line test, x never repeats. But if I gave you like our graph of sine, okay, do I ever hit the same y value more than once? If I'm looking at this, we do. So is sine 1-to-1 as it is? No. So that's going to be kind of the twist here when we do these inverse trig functions. We can't look at the entire trig function because they're waves. They keep repeating. We hit the same y values over and over and over again. So we're going to have to take just small sections of our graph and talk about the inverse along those lines. So function passes vertical line test. Remember, we're talking about horizontal line test for 1-to-1. You can draw a horizontal line that hits it more than once. It's not 1-to-1. When we find an inverse, we just reverse x and y. So that's all stuff that we know. Let's talk about domains and ranges for a second. If you find an inverse, the x becomes the y. So the domain of the original one equals what in your inverse? Okay, so when you find an inverse, your x's turn into y's, right? So the domain of your original, the x's in the original, those become the y's in the inverse, so those become the range. So the domain of the function is equal to the range of the inverse. The range of the function would equal the domain of your inverse. So on your little notes handout, I kind of gave you a condensed version of what I set up here. So I gave you a fill in the blank. The domain of f equals the range of f inverse. We use that f to the -1 to represent inverse. The range of your function is the domain in the inverse. So filling in those blanks. Also, you talked about in Algebra 2 and College Algebra, because x and y just reverse, they are reflections across the line y equals x. If you ever drew that, graphed that identity along with the function in the inverse, you would see that they are reflections. So that's the other fill in the blank piece. Okay, so let's talk about how we find an inverse. We always, if we're starting with something with a function, we have to change our f of x and replace it with, what variable is f of x the same as? Y. F of x is the same as y, so you change your f of x to a y. Then we switch the x and the y values. Then we want to put it back in function notation, so we'll have to solve for your y. And final step, just to denote the inverse, instead of y, we put that f to the -1 of x. So those are the steps we went through in algebra every time we did the inverses. Okay, so now we have to relate all of this to our trig functions. Because the issue, like we already said, our functions aren't 1-to-1. So we have to pick a portion of our graph that we could find the inverse of. So sine. We graphed that in chapter 4. We know the graph looks roughly like this, but it doesn't just stop. It keeps going in both directions. If I wanted to get that entire graph, I would need to capture the positives and the negatives, right? What we want to do is take a section of this graph, one nice continuous section where we would get all of those, the positives and the negatives. So if I graphed it, oh, sorry, my TV doesn't like my active Inspire stuff. So if I wanted one portion that would have all of it, we could take this segment. Would you guys agree that little segment is 1-to-1? That part passes the horizontal line test? Yeah. And that gives me every possible value of sine, everything from -1 to +1? Yeah. Okay, so what two quadrants would that represent?
Quadrant 1 and 3.
Close. This is quadrant 1. This is kind of going backwards. So if you think about like your unit circle. Okay, so we have quadrant 1, the 0 to pi/2. The other one we're looking at is quadrant 4. So when we're talking about sine, to get the positives and the negatives, we're going to have to use quadrants 1 and 4. For each of these on your handout, I kind of gave you the box that summarizes this stuff. There's a few blanks you have to fill in. Notation for the inverse, we use sine to the -1, or you might see arc sine. I know ACT sometimes does arc sine. They use both notations. They both represent inverse. Domain and range flip roles. Now typically, sine has a domain of -infinity to +infinity. We could graph it forever. But because I have to take one section to get the negatives and the positive, we are going to go from -pi/2 to +pi/2. The domain is the range of the original. Original sine has a range of -1 to 1, so that becomes the domain in your inverse. So in that box on the bottom of your first page, you need to fill in your domain and your range. The most important piece, what I need you to get from today. We're talking about a lot of the information, but really what it's going to come down to, the piece I'm going to assess, is evaluating these problems. You have to know the quadrants. For sine inverse, we will be in quadrant 1 or 4. Basically, we need 2 consecutive quadrants. Our options will either be 1 and 2 or 1 and 4, because quadrant 1 always gives us the positive. We pick the second one based on where it's negative. So sine is positive in quadrant 1, negative in quadrant 4. Those are the 2 quadrants we will use if the original problem has an inverse sign in it.
Wouldn't the same be true then in quadrant 3?
Yes.
It is negative.
That is very true, but we want consecutive quadrants. So because 1 and 3 aren't consecutive, we don't use that one. Okay. So very good point. All right, so here's how we're going to evaluate these. I want to find y in each of these equations. So it's like questions we've done before, however, we are starting with arc sine, or sine inverse. When we start the problem that way, we are limited on our quadrants. When I start with arc sine, I know I'm either in quadrant 1 or quadrant 4. Then I look at this argument to decide positive or negative. So it is a positive 1/2. Is sine positive in 1 or in 4? Okay. So then, when we evaluate this, we just need the angle in quadrant 1 that makes sine equal to 1/2. So when is sine 1/2? 30 degrees, or pi/6. If I don't specify in the problem, you could give me either. Most of the homework, you'll have a section where it says give it in degrees, and a section that says give it in radians. All right, let's look at another one. Sine inverse of -1. Okay, we know sine inverse can only be quadrants 1 or 4. So if you're looking here, if it's negative, we're talking about quadrant 4. We're looking essentially at this half of our circle. Sine is the y. When is it a -1? 270 degrees. So 270 or 3 pi over 2. I am going to tell you, if you're checking your answer in the back of the book, they are going to call that -90 degrees and a negative pi over 2. I don't care. Okay, I will take the coterminal. So you can give me, I'm assuming you will probably stick with 270 and 3 pi over 2, but just don't think your answer is wrong if you look in the back and they called it a -90. They end at the same point. Next one. Alright, sine inverse of -2. So sine inverse, it can be quadrant 1 or 4. If it's a negative, it's quadrant 4. When does sine equal 2? It doesn't. Think about the graph of sine. It falls between -1 and +1. Can it ever equal -2? No solution. Alright. Is that okay? So that's just our warning. Be careful. Make sure I might throw some values in there like that we can't solve. So let's talk about cosine. We need 2 consecutive quadrants, a positive and a negative. So we know we're going to pick quadrant 1 every time because everything's positive in quadrant 1. Is cosine negative in quadrant 2 or quadrant 4? Quadrant 2. So for cosine inverse, we pick quadrants 1 and 2. So you can fill in domain and range. I have up here, domain will be from -1 to +1, just like with sine. The range, because we're stuck in quadrants 1 and 2, between 0 and pi. All right. So let's look at a couple of those. Y equals arc cosine of 1. So we know cosine inverse is 1 or 2. It's positive, so that would be quadrant 1. When is cosine equal to 1? That's when it's negative. Just 0. 0 degrees or 0 radians.
I'm hating myself over here, don't worry about it.
Okay. Cosine inverse of negative radical 2 over 2. So we can be in quadrants 1 or 2 because I have cosine inverse. If it's negative, it's quadrant 2. Reference angle. When is cosine radical 2 over 2? So 45 degrees in quadrant 2 is 135 degrees. If I ask for it in radians, 45 is like pi over 4. So that would be 3 pi over 4. Again, you're not going to have to give me both the degrees in radians. You'll just have to base off the directions, depending on how I ask for it. one more. If I said cosine inverse of 1/2, in which quadrants is cosine inverse in? 1 and 2. 1/2 is positive, so that would be quadrant 1. So when we do that, when is cosine 1/2?
5%. Oh wait, that's pi over 4. Or 3. I'm gonna get myself.
Yes, pi over 3, or 60 degrees. If you're looking at your unit circle, it's when the x is 1/2.
I'll get it right one of these days.
Takes a little bit. Okay, let's talk about the others. Again, the piece that I'm really worried about, the homework might ask you some questions about domains and ranges of these, but on the test, your test will be just questions like this. Y equals cosine inverse of negative radical 2 over 2. So what you really need to get from this is what quadrant we're in, and then it's just unit circle questions. Okay, so the thing you have to remember is the quadrant. I would give you a blank unit circle and you could fill it out. So yes, if you want a unit circle when it comes time for the test, just make sure you know how to fill it out still. Alright, tangent. So if I'm trying to pick my quadrants, we know everything's positive in quadrant 1, so we're going to take that. Tangent is negative in both 2 and 4, so it could really be either one, but remember when we graphed tangent in chapter 4, we went from negative pi over 2 to positive pi over 2, so we wouldn't have an asymptote in the middle. So when we graph tangent, we already did quadrants 1 and 4, and that's what we will use now as well. So, domain and range you can write down. Like I said, I'm not testing you on that part. What you really, really need to know is your quadrants. It's 1 and 4, just like when we graphed it before. We always graphed it from negative pi over 2 to positive pi over 2. Cotangent, when we graphed it before, we went from 0 to pi, which was quadrants 1 and 2. So we're going to stick with those when we do the inverse. So, cotangent, you can get your domain and range. Our quadrants are 1 and 2. So secant is the reciprocal of cosine. What quadrants did we use for cosine inverse? So we're going to do the same thing for its reciprocal. And then cosecant, oh sorry, domain and range are up here. It has an asymptote right in the middle. That's why your domain looks a little funny. Cosecant is the reciprocal of sine, so we will graph it the same way we do sine. So with sine inverse, we went quadrants 1 and 4. So we will do the same thing for cosecant. So basically to summarize, when we do these inverses, we'll either be in quadrants 1 and 2, or we'll be in quadrants 1 and 4. 1 and 2, you'll have cosine, its reciprocal secant, and cotangent. 1 and 4 are sine, its reciprocal cosecant, and tangent. So that is the piece that you need to remember, the quadrant.
So is it too late to go back to last unit?
Oh, this is not bad. It's just unit circle stuff. And all the quadrant's doing is, instead of telling like every time on the unit circle sign is 1/2, we just have to answer it. It'll only be one answer based on the quadrant. So now we just need to practice some of this. Okay, so example 3, I'm asking for degrees on these. So theta equals arctan of 1. That means tangent inverse of 1. So when I see tangent inverse, I know automatically it can either be in quadrant 1 or quadrant 4. Because 1 is positive, we're in quadrant 1. So I'm just asking myself, in quadrant 1, when does tangent equal 1? 45 degrees. That's all I have to do. If you've got your unit circle filled out, you just look in your quadrant and find the appropriate angle. So B, when secant inverse is 2. If you're not comfortable with like cosecant and secant, you are welcome to rewrite it. This means cosine is 1/2 if you're more comfortable with that. So we know secant and cosine, they exist in quadrants 1 and 2. It's a positive 1/2, so we're in quadrant 1. When does cosine equal 1/2? 60 degrees. And that's our answer.
For that last one,
Mm-hmm.
when you got 45 degrees,
Mm-hmm.
what did you do?
We knew it was in quadrant 1, so
Yeah.
we didn't have to really worry about the reference angle. So I was just asking myself when tangent would be 1. So it's just like the hand trick, or if you're looking at your unit circle, if tangent's 1, x and y have to be the same.
Oh. Okay, thank you.
You're welcome. Anything else? Okay. So let's talk about if I give you one that is not one we have memorized, and we have to use the calculator. On the calculator, here's my bit of advice. Never type in a negative angle. You will get the right answer sometimes, and sometimes you won't. Basically, you'll get the right answer unless you're dealing with cotangents, because we have to use the tangent button for cotangent, but tangent inverse and cotangent inverse exist in different quadrants. So instead of remembering all of that, what I want you to do is when you're putting in the calculator, always just type in a positive and then we will place it in the quadrant we need to. So for example, find y in radians if y equals cosecant inverse of negative. First of all, I did say in radians, so make sure your calculator is in radian mode. Okay, do we have a cosecant inverse button on our calculator? No. So what this means is that cosecant of y is equal to -3. We can't do cosecant, we have to rewrite it. Cosecant's the reciprocal of sine. So I'm looking to see when sine is -1/3. Which quadrants can we be in for cosecant or sine inverse? It was a -3, so we're in quadrant 4. We're going to use our calculator to get the reference angle. So what you're going to type in is sine inverse of a positive 1/3. Then, if I want to put that in quadrant 4, you would do, we're in radians, so 2 pi minus that. So 2 pi minus 0.3398. And my actual angle is 5.9434. So let's look at B.
When you type that in, do you put pi?
To get this,
Yeah.
yes, it did 2 pi minus that. Alright, B, I asked for degrees, so change your mode to degrees this time. Okay, arc cotangent is 0.3541. So what that means is cotangent of some angle is equal to this. Which quadrants can I be in for arc cotangent? It was a negative, so we're in quadrant 2. To type this in, since we don't have a cotangent button, we're going to have to do tangent. So that means tangent is 1 over that. We type in the positive, so you will do tangent inverse of 1 over 0.3541. I get 70.5009 degrees for the reference angle. Then how do we put that in the appropriate quadrant? Pi, but we're in degrees, so we'll do 180 minus that. So our final answer is 109.4991 degrees. So just be careful when you're doing these on the calculator. Don't type in the negative. Put in the positive and then use reference angles to put it in the correct quadrant. Okay. For some reason, I don't think my very last example printed. I don't know if I... So just flip it over. This is my last example. I think I only have one question on the homework like this. I want to evaluate this without a calculator. Sine of tangent inverse 3/2. So an inverse gives you an angle. We basically need to find sine of that angle. Without using a calculator, I'm not going to be able to find my angle exactly, but what this tells me is tangent from that angle is a positive 3/2. So if I set up a triangle, tangent is opposite over adjacent. Okay, could we find the missing side?
Sure.
Yeah, a squared plus b squared equals c squared. So I get my hypotenuse to be radical 13. So now all we need is sine from that angle. Sine is opposite over hypotenuse, so 3 over radical 13, which is 3 radical 13 over 13. So we never actually found the angle, but we didn't have to. one more along those lines, and then I'm done. So again, this just represents some angle, and we have to find tangent of that angle. Now cosine inverse can be in which quadrants? 1 and 2. Since this was a negative, I need to draw this triangle in quadrant 2. Cosine is adjacent over hypotenuse. So b squared is 144. Square root, we would do plus or minus, but in the second quadrant that y would be a positive, and that's a 12. So tangent to theta, opposite over adjacent, is negative 12. Any questions there? So I have taught this whole section. Tomorrow, we are going to have part of the class as a work day for this homework, and then towards the end of the class I am going to start the next section. Probably won't give you much homework out of the next section yet, but I might do the examples from it. So I'm trying to give you some in-class time to work, but not a full class period. I am going to move on after a while. But this is the assignment. You've got a little bit of time.